Hi everyone, in this video we're going to look at oligopolies and finish our exam review for this second exam, and this covering the chapter that covers oligopolies and game theory. So the first thing we can notice, or first thing we kind of talked about with the oligopoly was game theory. That's kind of the how we study how when there are just a couple firms, how they can make decisions. So with game theory, what we're going to look at is how people or firms make decisions or behave in strategic situations, right? That is where my decision impacts what the other person does, and what the other player does impacts what I do. So in game theory, one of the big things that we have is a decision to compete or cooperate. Right, so we can either compete with each other, or we can agree to both charge higher prices, or to put ourselves in maybe a better situation for us. So in this cooperation case, we see it's kind of hard because we get into what's called a cartel, right? And this is when firms act in unison to maybe charge a higher price, or whatever they need to do to maximize their profits together. However, for this, in order for a cartel to work, we need our firms to agree on one, what price to charge, and two, what quantity to produce. Right? And these kind of go hand in hand, right? So if we fix a quantity, we're going to get a price from that. Similarly, if we set a price, we're going to have a fixed quantity for that. But with these, right, we get this scenario where we have this decision to make, and we come across this type of chart. So suppose we have a Shell and a Casey's gas station, and they have a choice to charge either a high price or a low price, right? And same thing with Shell. They have a choice to go either high or low. And we'll see if they both choose a high price, right? Suppose that they can both make, right? Suppose they both pick a high price. They both get, say, $7 million of profit. Make this look nice. However, if Casey's decides to go low, right, more people will shop there. So they maybe get $10 million of profit, while Shell is left with, say, $4 million. And vice versa, if Shell goes low and Casey's stays high, Shell gets $4 million. Oops. Yeah, Casey's gets $4 million, while Shell will get $10 million. And if they both go low, they both end up with, say, $6 million. So in this case, when we're in this situation, we end up wanting to find is two big things that come up a lot. Is one, the dominant strategy. And to find this, we can kind of do our little thing with I mentioned in class, we can do our little dots. So if I'm Casey's and I know that Shell's going to charge a high price, I have a choice to either make $7 million or $10 million, in which case I'm going to pick that $10 million and go low. Similarly, if I know that Shell is going to charge a low price, I have a choice to either have $4 million or $6 million, in which case I'm going to charge a low price and take that $6 million. Now, for Shell, Casey's and we know that Casey's is going to go high. We have a choice of either 7 or 10 million, in which case we will pick that $10 million. And similarly, if we know that Casey's is going to go low, we have a choice of either $4 or $6 million, in which case we charge $6 million. So in this case, to find the dominant strategy, again, we can just look for a row for Casey's or a column for Shell. So in this case, for Casey's, we said their dominant strategy is to charge a low price. And same thing for Shell. Their dominant strategy will be to charge a low price. Again, that's because no matter what Shell does, Casey's better off going low. Similarly for Shell, no matter what Casey's does, Shell's better off picking a low price. So the next thing that comes up with this could be, what is our Nash equilibrium? In this case, a couple of ways we can think about it. The way I like to think about it is we're looking for a box or a situation with 2 dots. So in this case, our Nash equilibrium would be right down here where they're both charging a low price. So in this case, we might say Nash equilibrium when both firms charge a low price. And we can also write this out, if you're more mathematical, NE at low, low. So that's how we find Nash equilibrium and our Nash equilibrium and our dominant strategies. And if you're in a situation where, right, and we can add on, so if we added on, say, a third choice, right, you'd have a similar situation. So suppose we had another game where you had, say, Tony and Mark. And suppose we think about the game rock, paper, scissors. Right, so for this game, right, you have a choice, either rock, paper, or scissors. And same thing with Mark, has a choice between rock, paper, and scissors. Right, and for each of these, we get a payout. And in this case, we're going to say that if we win, we get $1. If we lose $1. And if we tie, well, we both don't get really anything. So in this case where they both tie, right, across the board, they both end up with 0 because it's a draw, right, everyone gets their $1 back. Now, if I'm Tony and I know Mark goes rock, if I pick paper, I get $1 and Mark loses $1. However, if I'm Tony and I go scissors and Mark takes rock, rock beats scissors, so we have a -1 and a 1. Up here where we have Tony picks rock and Mark gets paper, Tony loses and Mark wins. And down here we have that Tony wins and Mark loses. And then over here in the scissor column, if Tony does rock and Mark does scissors, Tony wins and Mark loses. And if Mark goes scissors and Tony goes paper, Tony loses and Mark wins. So if we have a 3x3 case, just treat it like a 2x2, just with one extra choice. So if I'm Tony and I know that Mark is going to pick rock, I have a choice to either tie, win, or lose, in which case I'll take paper and win. If I know that Mark picks paper, right, I have a choice to either lose, tie, or win, which again, I'll take scissors and win. And if I know that Mark is going to pick scissors, I can either win, lose, or tie, in which case I will pick rock and win. And we can do the same thing for Mark. If Mark knows that Tony picks rock, Mark will pick paper. If Mark knows that Tony does paper, Mark will do scissors. And if Mark knows that Tony does scissors, Mark will pick rock. So in this case, when we think about, and if we have a game, it can come up anyway. But in this case, if we think about dominant strategy, right, we see that there's none just because there's no rows of dots and there's no column of dots. And for Nash equilibrium in this case, Again, we also see none because there are no situations where they're both going to pick no matter what. Right. But if we have a 3x3 game, just treat it like a 2x2 game. Just instead of having 2 choices to choose from, you have 3 choices to choose from. And the last little bit that we said, the situation that we mentioned above, we talked about the prisoner's dilemma, right? And this kind of goes back to our Shell versus Casey's game. And what we see in this case is that we kind of see a couple things. One, each player chooses their dominant strategy to reach Nash equilibrium. Right, and what we'll see is they both have dominant strategies, and it's also going to be difficult to collude, just because you can't trust the other player. Can't trust the other player because if they're rational, they will not cooperate with you. And what we'll often see happen is that we fail to reach our best joint outcome. Right? So in the case above, right, they both would have been better off to just charge the higher price, but it's hard to reach that point because you're better off to charge a lower price, and it's hard to get that cooperation. Same thing in the standard case where we're both considering going to jail. Right? If you trust your friend not to tell on you, maybe you cannot tell, but you know if they tell on you and you don't tell, you're going to be put away for a long time. And because of that, it's just hard to reach that joint outcome. So this should be good for you and helping you prepare for the exam. If you have anything come up, let me know, and I'm always happy to help. Have a good day.